In this lesson, we are going to look at continuous relations, and specifically, we're going to look at how to determine the domain and the range, and also to tell if it is a function using something called the vertical line test. But first, what is the difference between continuous and discrete? I don't know if you can remember, but the previous section was called discrete. Okay, now that's not that important, but let me just quickly show you. With discrete, you have individual little dots. Remember in the previous lesson we plotted random dots, and from that we could see if it was a function or not. And in this lesson, okay, well, let's first say here that this is discrete, and then continuous is more when we look at curves and lines like that. You see, it's not individual little dots, it's more like a curve or a straight line or a circle. Those are continuous because they continue. You see that? Whereas discrete, the word discrete means when maths, or in this section, it's like individual little dots. All right, so that's the main difference there. Now, here we go. So what they're going to do is they are going to give you some type of graph, okay? And from that, you need to be able to work out the domain, the range, and then you also need to be able to tell if it is a function or not. And we're going to do a lot of examples in this lesson where I'm going to show you exactly how to do this. So remember that the domain is all of the x values. Okay, so what you're going to do, step one, find the smallest x value. Find the smallest x value. So remember the x values are these ones, okay? So the smallest one would be over here, okay? So that's going to be at -4. Step 2, find the largest x value. Now, a lot of you are going to say 8. I know that. You're going to say, oh, look, it's there, it's 8. But what you got to look out for is the arrow. So because there's an arrow, it actually means that this graph never, ever stops in that direction. Whereas on this side, it did have it stopped over there. So the biggest x value is actually going to be infinity. Okay? Right, so that's how you can work out the domain. So what we'll now do is you can write it in two different methods. You can use interval, or you could use the inequality method. Okay, so if you use an interval, then what you use is brackets. Okay, now this -4, we're going to use a square bracket. Why? Because can you see at the -4, it is a solid circle. Remember when we looked at inequalities, and we sometimes had a number line? Sometimes it was a solid circle, and sometimes it was an open circle. If it is a solid circle, we use a square bracket. If it is a round circle, you use a curvy bracket. Okay, so that's going to go -4. And then what is the largest one? Well, that's infinity. And then infinity is always a round bracket. Okay, so infinity always uses a round bracket. There we go. If you prefer to use inequality symbols, you know, where you use this or that or this or that, then what you would do is you would do the following. You'd say x is any number that is bigger than or equal to -4. Let me explain. Look at all of these x values, all of them. Like, for example, this is -3, -2, -1, 0, 1, 2, 3, 4, 5, 6. All of those x values are bigger than or equal. I'm saying equal to as well because that's a solid circle. They are all bigger than or equal to -4, right? These numbers are smaller than -4, but we don't want those. So you would say x is bigger than or equal to -4. Okay, so that is the two different ways that you could write out the domain. You don't have to use both. You only have to choose one of those, whatever you're comfortable with. Okay, now we're going to go do the range. Now remember that the range is the y values. So we're going to go do the same exact procedure though. So let's do that. Right, so the steps are the same. So the first step is find the smallest y value, okay? And then you're also going to find the largest y value. So it's always the smallest one first. So let's go find the smallest y value. So remember, small y values are at the bottom and large y values are at the top. So the smallest one, well, if this arrow just keeps going, then the smallest y value is probably going to be way down at negative infinity. Negative infinity. Positive infinity would be at the top. Negative infinity would be at the bottom. Okay, now what is the largest y value? Well, the largest y value is the highest place on the graph, and that would be at this point over here. It doesn't go any higher than that. So that would be at 2. Now, is the 2 included? Yes, we can see that it is touching the value of 2. Although it doesn't have a little dot there, they only show dots at the end. Okay, but we can see it's definitely touching the 2. So what you can do, if you prefer to use interval or the inequality, I'll show you both. So for the interval, you would go, okay, so the smallest y value, always do the smallest one first, okay? That's important. Always the smallest one first, which was minus infinity. Remember that infinity always gets a round bracket. And then the 2 was the largest y value, and we include it because it's touching the 2, okay? If you prefer to use interval notation, you can say that all of these y values are smaller than or equal to 2, because they are all smaller than or equal to 2. So for example, this y value is a 1, this one's y value is minus 1, this one's y value over here is minus 2, and it just keeps going smaller and smaller and smaller than 2. Okay, so that's how you would write out the inequality symbol for that one. Right, now here's the big question for number 3. Is it a function? Well, it's a very easy way to do this. You use something called the vertical, let me write this down for you guys, vertical line test. So as the name suggests, we are going to draw vertical lines. So if you had to draw a vertical line there, how many times did you just cut the graph? Well, you just cut the graph once. If you do it here, oh, you just cut the graph once. If you do it here, cut the graph once. If you do it here, you cut the graph once. And if you do it here, if you do it anywhere on this graph, how many times will the vertical line cut? It only cuts once. So we can say that the vertical line only cuts once. Therefore, is it a function? Yes. Yes, it is a function. So let's quickly summarize. How does the vertical line test work? Draw vertical lines on the graph. If it cuts once, then it is a function. If it cuts more than once, then it is not a function. Then it is not a function. Okay, and we will look at some examples like that in this lesson, where it won't be a function. So let's try this one. So remember that the domain is all the x values. Okay, so let's do that. So to find the domain, we first look at the smallest x value, and then we also look at the largest x value. Okay, so the smallest x value, remember small x values go this way, large x values go that way. So the smallest one would probably be here, right? This one over here. You don't get any more left. There's no, the most left part of the graph is this part over here. I hope that makes sense. That is the most left part of the graph. So that is at an x value of minus 1. Okay, then the most right part of the graph would be this point over here. Can you see the graph? The graph doesn't carry on because there's no arrow. Okay, so the graph stops over there. Now what is the x value there? It's 2. Okay, so if we want to write out the domain, you can have 2 options. Remember, you can say interval, but you only have to do one of these, or you can use the inequality. So if we use interval, then we are going to put the number minus 1 and 2. Now, we need to check. The minus 1, the graph is touching the minus 1, so we can put a square bracket, because remember, a square means included. Round means excluded. So if we look at the 2 now, there's an open circle, so that's not included, so we'll put a round bracket. If you wanted to use inequality symbols, you could say that x is any number bigger than or equal to -1 and smaller than 2. Let me quickly explain that. So we know that all of these x values, right? These x values from here, it's -1 up to 2. So all of those x values between -1 and 2, they are bigger than -1, but they're smaller than 2. And that's what this says over here. It says that x is bigger than -1, but at the same time, it is also smaller than 2. Many learners prefer this one because some learners do struggle with this whole inequality notation, but some learners do prefer it. So that's fine if you want to do that. Okay, so there's the domain. Now let's do the range. So remember, your range is all the y values. So we need to go find the smallest y, and we need to go find the largest y. Remember that your smallest y is at the bottom, and your largest y is at the top. So your smallest y is here is at -6, and your largest y is up here at +6. Both of them have an open circle, so they are not included. So for interval notation, you could use a round bracket and say -6, and then a round bracket again at 6. Always starting with the smallest number, going to the largest number. Okay, if you prefer inequality, then you would say that the y value is any number that is, not equal to, bigger than -6. So any number bigger than -6, but also smaller than 6. So it's somewhere between -6 and 6. Okay, and then is it a function? Well, remember what we do? We just go do vertical line tests. So we just draw some vertical lines. Ooh, it actually have a look here. If we do a vertical line, look at that. Cuts once and cuts twice. But what if we draw a vertical line here? Now it only cuts once. So what do we do? Well, if it cuts more than once at any place, then it's not a function. So is this a function? No. Why? Because the vertical line cut more than once. Even though it doesn't do it there, that doesn't matter. As long as it does it once anywhere, then it's not a function. So this one is not a function. I'm going to start moving a little bit faster now. So for domain, we know that that's all the x values. So we look for the smallest and we look for the largest x value. Okay, so the smallest x value would be over here. Right, because that's the most left part of the graph, so that would be -5. And the most right part of the graph, which would be the largest, would be at 7. So if we wanted to write this using interval, or I'll do it like this, inequality, then it would go like this. For interval, both of those numbers are included because the graph is touching both of those points. There's no like open circles or anything like that. So we would say -5 and 7. Always doing the smallest number first and then the largest. For inequality, you would say x. Remember, domain is all about the x. Range is all about the y. You would say that x is any number bigger than -5, bigger than and equal to, and smaller than and equal to 7. Okay, now I'm going to do the range, which is all about the y values. So the smallest y value, remember, so now you're looking upwards and downwards. So the lowest y value is here at -6. The largest y value would be up here at 4. Okay. So then you would say, if you use interval, you would say square bracket, -6 and 4. Always the smallest number first. And then for inequality, you would say that the y values are bigger than or equal to -6, but smaller than or equal to 4. So the y value is anything between -6 and 4. Then, is it a function? Well, check these out. If I draw some vertical lines, how many times does it cut the graph? Well, twice every time. Yes, if you draw it there or there, it maybe only touches the graph once. But look at all these places. Its vertical line is cutting more than once, so that's not a function. It's not a function. It's only a function if the vertical line cuts once. Let's start with the domain. So for domain, we know that that's always the x values. So we're going to look at the smallest x value. And then we'll also have to look at the largest x value. So the smallest x value, so now you're looking left and right. So the smallest one is the most left one. So that would be this one here. I know this looks like a previous example, but it is a little bit different. So the smallest x value would be this one, which is at -2. The largest x value, so now you look to the right-hand side. Some of you might say it's this, but you would be wrong. Look at the arrow. Woo! The arrow means that the graph just keeps going forever and ever and ever and ever. So it would keep going. Obviously, I can't keep drawing, but it would keep going. So that x value would just keep getting bigger and bigger and bigger and bigger. So your largest x value is actually going to be infinity, positive infinity. Now, so the way we write that then, if you want to do interval, and because remember that, guys, you've got to be careful, hey? This one had a solid circle, so it stops there, whereas this one has an arrow, so it just keeps going. So if you use interval or if you use inequality, alright, so for interval notation, well, there you would say a square bracket -2, because that's the smallest x value, and it touches the -2, so that's included, and then you'd go all the way up to infinity. Now remember, infinity is always round. If you use inequality, then you would say x is any number bigger than or equal to -2. What does that mean? It means that x can be -2 or bigger. So -2, -1, 0, 1, 2, 3, 4, 5, 6, 7, and all the way to infinity. So x can be anything bigger than or equal to -2. All right, now we're going to look at the range, which is always the y values. Okay, so the smallest y, well, then you go down. Well, that's just going to go all the way down if you follow the arrow. So that's going to go down to, don't say infinity, it's minus infinity. Positive infinity is that way at the top. Okay, and then the largest y value, well, that goes up to here, right? And it doesn't go further because it doesn't have an arrow. So that would be 6. Okay, so if we use interval, then you would say always the smallest one first. So minus infinity. Round bracket, because infinity always uses a round bracket, and then the 6 has a solid circle. It's not an open circle, so that would be a square. If you prefer inequality, then you would say that y can be any number that is smaller than or equal to 6. What that means is that it can be 6, but then it can also be anything smaller. 5, 4, 3, 2, 1, 0, -1, -2, -3, -4. And it goes all the way down to minus infinity. So that says y can be any number smaller than or equal to 6. Now, is it a function? Well, if I do a vertical line test, boom, look at that. It cut more than once. It cut twice. It could even cut 3 times on some types of graphs. But as long as it cuts more than once, then it is not a function. And here is our last example. I wanted to include this one because it's got arrows on both ends. Oh, okay. So let's look at the domain. Well, if you go to the left, the most left x value would be this one here at -5. So let's say the smallest x value is -5. The largest x value, well, that means you must go all the way to the right. But look at these arrows. So that graph will just keep going. So the largest x value would be infinity. So if you want to use interval notation, or interval method, sorry, or inequality. Okay, so for the interval method, you could say from, the -5 is included, yep, and then it will go all the way to infinity. Infinity is always a round bracket. If you wanted to use inequality, just ask yourself, what x values are we allowed to have? Well, you can have any x value that is larger than or equal to -5. So you could say x can be anything larger than or equal to -5. Okay, and this would be for domain. Now we're going to quickly do range. So the smallest y and the largest y. Okay, so the smallest y, if you just follow the arrow, it's just going to keep going down, 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 down. Some of you might say, yeah, but Kevin, this is eventually going to become flat. Yeah, it actually doesn't. So it just keeps going, 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 going. So the smallest y value will be minus infinity, and the largest y value will be infinity. So when you get infinity and infinity like this, then you've got multiple ways of writing it. So for interval, and then for inequality. Okay, so for interval, you could just say from minus infinity using a round bracket to positive infinity using a round bracket. For inequality, you actually don't do this. You don't say y is bigger than minus infinity and smaller than infinity. You don't really do that. What your teacher will probably do is you'll just say that all real numbers. There we go. So when it's infinity and infinity, your teacher will just say, if it's negative infinity and then positive infinity, your teacher will just say all real numbers. That means that it can be any number. Okay. And then is it a function? Well, if I draw a vertical line, it cuts more than once. So because it cuts more than once, we will say no, it's not a function.